Hello there. During this session I'm going to be talking about transformers, not robots in disguise, but a device for changing the voltage flowing through an alternating current circuit. Okay, so let me explain. So we have a transformer in front of us, and what happens is made up of a soft iron core, and on one side there's a primary coil. So we have coils of wire going around, and that has the initial input, and then the output comes out of the secondary coil, and again that has a number of coils of wire around the soft iron core. Now what happens is the alternating current going into the primary coil, as the current is alternating, it causes a change in magnetic field. Now, the associated magnetic flux linkage, or the change in magnetic flux linkage, is transferred through the laminated soft iron core, and that causes an induction of electricity in the secondary coil. So in this case we have 2 volts going in, and then we have 8 volts going out. So as we can see, there's a change in voltage, but it has to be alternating current. Direct current obviously would not work, because it wouldn't cause a change in magnetic flux linkage, and therefore it wouldn't induce electricity in the second coil. If we look a little bit more closely at these, we have 2 types of transformers. One type of transformer is a step-up transformer. This increases the voltage. And then we have a step-down transformer, which decreases the voltage. And as you might be able to pick here, the relationship between increasing voltage is directly related to the relationship in number of turns in the primary and secondary coil. So I'll give you the formula we'll use for this calculation. Secondary voltage divided by the primary voltage. So that's the voltage going into the primary coil is the primary voltage, and the voltage coming out of the secondary coil is the secondary voltage, is going to be equal to the number of turns of the secondary coil divided by the number of turns of the primary coil. Quick note here, the voltage you use must be consistent. So if you're using the root mean squared value for voltage for the secondary, then you need to be using it for the primary. If you're using the peak voltage, then you need to use the peak voltage. So as long as you're consistent, this calculation works every time. Ideally, a transformer is 100% efficient. So that means what we find is the power from the primary coil is equal to the power in the secondary coil. So current times the voltage if the primary coil is equal to the current times the voltage of the secondary coil. That's if everything is 100% efficient. There are some energy loss issues, and the energy loss issues are related to the fact that obviously the copper wire causes a loss because there's some resistance in the wires. We have hysteresis loss, and that's because magnetizing and demagnetizing the iron core uses up power itself. I also have a thing called eddy currents, and these are small currents which form inside the core itself. And actually one of the ways to decrease this is by creating insulating layers inside the iron core, and that reduces the eddy currents and therefore makes it more efficient. So that's a very quick overview into transformers. I hope that helps.